This video audits the official story of the Easter Island moai, a narrative that collapses under the most basic real-world constraints. The official explanation for how a remote culture moved 50-ton giants is a production system that claims a 10 to 15% failure rate, a number so high it invalidates the entire premise from the start. Look, in any heavy industry, from shipbuilding to aerospace, a process that destroys 1 out of every 7 finished products is not a success. It is a catastrophic, systemic failure you would shut down on day 1. A simple check of waste loss metrics for any serious manufacturing operation shows a 1% loss is a crisis. 15% is pure fiction. How can a process that guarantees the destruction of its most sacred, labor-intensive creations be presented as a viable method for centuries of continuous work? The raw mathematics of this claimed failure rate are indefensible, colleagues. The official account states that roughly 900 statues were successfully installed on their platforms, the ahu. A 15% failure rate applied to the total number quarried means more than 150 of these multi-ton monuments were shattered and abandoned during transport. Think about the physical evidence this would generate. The island's ancient roads should be a veritable graveyard of broken gods, littered with the remains of these colossal failures. You can check the published archaeological surveys of the island's road systems. While some fallen moai are documented, the numbers do not create the landscape of industrial-scale disaster that a 1 in 7 failure rate would absolutely demand. Where is the physical evidence for a scrap heap of over 150 shattered monuments? This level of destruction isn't just a physical problem. It's a complete economic dead end. Each moai represented a massive investment of the island's most precious and finite resources. Years of time, generations of skilled labor, and countless tons of food. Do the simplest check. Calculate the man-hours required for a team of artisans to carve a 50-ton statue from solid rock. Then add the labor for the rope makers, the tool makers, and the farmers who had to produce a food surplus to feed this entire industrial army. Each failed statue isn't just a broken piece of stone. It's the equivalent of a community's entire gross domestic product for years, turned to dust. Reality does not care about romantic stories. No society, especially one on a small, isolated island, can sustain a system that knowingly flushes 15% of its total wealth into a ditch, year after year. What economic model allows for a system that institutionalizes such profound and predictable waste? The political and social fallout from such routine failure would be just as severe, if not more so. The statues were supposedly commissioned by competing chiefs to honor their ancestors, project power, and secure their legacy. The primary incentive, the entire point of the project, is the successful installation of the monument on its ahu. Be honest. A system that regularly fails to deliver, turning a symbol of a chief's power into a roadside ruin for all to see, would undermine the very authority it was meant to display. Think. A chief who commissions 3 statues over his lifetime and sees one shatter into pieces during transport doesn't look powerful. He looks cursed, incompetent, or forsaken by the gods. You can check the anthropology of any prestige economy. The public, ritualistic failure of a high-stakes project is a source of immense social shame and political weakness. How could the island's elite maintain their authority for centuries while presiding over a sacred process that so consistently and visibly failed? The very material chosen for the statues, volcanic tuff, is the origin point for this entire cascade of failure. The official narrative presents the stone's softness as a feature, claiming it was easy to carve with the available basalt tools, which is true. A simple check of the Mohs hardness scale confirms that harder basalt can indeed work softer tuff, but this convenience comes at a fatal cost. A trade-off no sane engineer would make. The very property that makes tuff easy to carve also makes it exceptionally fragile under the specific high-impact stresses of transport. You cannot cheat constraints. This isn't a balanced trade-off. It's a foundational engineering blunder that dooms the project from the start. Why would a culture of supposedly master carvers choose a material that is weakest precisely when it is put under the greatest and most unpredictable strain? Any practitioner who works with materials knows you select them based on the total life cycle of the product, especially the point of maximum stress. For the moai, that point isn't in the quarry, it's on the road. The proposed walking method multiplies the weakness of tuff exponentially. Every single step of the rocking process is a controlled fall, sending a percussive shockwave through the statue's most vulnerable points, the narrow angles, and the thin, sharp edges of the base. Look, you can model the physics of dynamic loads on brittle, non-uniform stone. It's not a question of if microfractures would form, but how many and how fast they would accumulate with every jolt. This is a textbook case of fatigue failure. How can the same people be brilliant, patient carvers in the quarry, yet commit to a transport method that is functionally a machine for generating catastrophic stress fractures? These accumulating microfractures would be invisible to the naked eye, growing with every step over miles of transport, until the statue failed catastrophically and without any warning. This introduces another fatal logistical problem: inspection and repair. In any modern heavy-haul operation, constant inspection for stress and fatigue is a non-negotiable part of the process. How would the Rapa Nui have done this? You cannot detect internal microfractures in a 50-ton block of stone with your eyes. And if a visible crack or a significant chip did occur mid-transport, what was the plan? Stop buying it. Tuff is not a material you can weld, patch, or glue back together. Any repair would be purely cosmetic, doing nothing to restore the structural integrity of the monolith. Were they gambling the work of years on the hope that no damage would occur over miles of brutal transport? Let's assume a crack does appear. What breaks first? The project's timeline and budget. The crew would have to make a choice: abandon the statue where it stands, writing off years of labor, or risk moving a compromised 50-ton weight that could shatter at any moment, likely killing the entire crew. There is no good option here. The lack of a viable repair protocol means any significant damage was a death sentence for the entire project. Reality does not care. Any real-world logistics plan has contingencies for predictable problems like material damage. The official story has none. Did they truly have no protocol for a damaged statue? Or was any visible flaw an immediate order to abandon ship and condemn years of work to the scrap heap? The very design of the statues themselves seems to actively conspire against their own survival during transport. The official story frames the distinctive D-shaped base and forward-leaning posture as clever features, engineered to facilitate the rocking, walking motion. But from a basic structural engineering standpoint, this design maximizes instability. Do the simplest check. A wide, flat, square base provides the greatest stability against tipping. A narrow, rounded base, combined with a high center of gravity, makes the object inherently tippy by design. You can build a simple scale model in your garage to demonstrate this fundamental principle. The statue is a classic inverted pendulum, an object that is actively trying to fall over at all times. Why would you deliberately design a 50-ton product that is engineered from the ground up to be unstable during the most dangerous phase of its entire journey? This design choice isn't just an abstract observation. It has direct, practical, and destructive consequences. The rocking motion concentrates the statue's entire 50-ton weight onto the very narrow, leading edge of the D-shaped base with every single step. This creates an immense point pressure on both the ground below and on the statue itself. You can calculate the pounds per square inch. It's an enormous force, guaranteed to pulverize any unprepared road surface, and, more importantly, to chip away at the fragile tuff of the statue's own base. Think about it. The transport method was a self-destructive machine, literally grinding itself and its path into dust with every single move. How do we reconcile the supposed design genius of the carvers with a transport design that is fundamentally self-abrading and dangerously unstable by its very nature? Now, let's audit the proposed transport equipment, which is where this story moves from difficult to impossible. The claim is they used ropes made from the fibers of the hau tree. Any practitioner who has ever worked with natural fiber ropes under heavy, dynamic loads will tell you they are a control nightmare. They stretch unevenly, they fray constantly, they weaken dramatically when wet, and they have wildly inconsistent breaking strengths from one rope to the next. You can test the tensile strength of hand-woven fiber ropes. While they can be strong, they are not uniform or predictable like modern synthetic cables. You cannot cheat the physics of tension and load. A system's reliability is only as good as its weakest, most unpredictable component. How did they manufacture hundreds of ropes with perfectly matched tensile properties to ensure uniform load distribution across the statue? The lack of uniform rope strength is a critical failure point. Imagine the scene. A team of 15 to 20 adults is supposedly coordinating the pulls on these organic ropes to rock and pivot a 50-ton monolith. A single rope snapping, or even just stretching a few inches more than the others, would instantly throw the entire system out of balance. The statue would lurch. The load would shift catastrophically to the remaining ropes, and those ropes would be subjected to a sudden shock load far beyond their capacity, leading to a chain reaction of failures. Look. Perfect, synchronized tension across 24 organic, unpredictable ropes, maintained by 20 human operators for hours on end over uneven terrain, is not a realistic operational plan. It's a recipe for certain disaster. What was the command and control system for ensuring every single puller applied the exact same force at the exact same instant, every single time? This brings us to the human factor, the most fragile component in this absurd system. What breaks first
in a high-stress, low-reliability system. People. A 50-ton statue falling is not a minor workplace incident. It is a lethal event that would instantly crush anyone and anything in its path. With a claimed failure rate of 1 in 7, these disasters were not a remote possibility. They were a regular, predictable, and accepted feature of the job. You can calculate the kinetic energy of a falling moai. It's equivalent to a fully loaded semi-truck dropping from a multi-story building. The teams of 20 adults were not standing at a safe distance. They were right in the kill zone, holding the very ropes that were the system's most likely point of failure. How did the island's leadership convince generations of its most skilled workers to participate in a project with such a high probability of gruesome, lethal failure? The sheer risk to the workforce fundamentally invalidates the core incentive structure of the entire project. The enterprise was supposedly driven by elites to honor ancestors, ensure fertility, and project power. The primary goal, the only goal that matters, is to get the statue successfully installed on its ahu. Be honest. A system that regularly kills its own skilled workforce is directly counter to that incentive. It depletes the very resource, skilled labor, needed to continue the project. At some point, the cost in lives, resources, and shattered honor would become unbearable for any society. You can check the principles of operational risk management.
In any field, you always design the system to minimize the catastrophic failure points. The walking method seems to deliberately maximize them. It places fragile material under percussive stress, uses an inherently unstable design, is pulled by unreliable organic ropes, and is operated by humans placed directly in the path of certain death. Why would a culture invest centuries of effort into a system that so consistently and dangerously failed to deliver on its only promise? The official narrative often deflects these glaring problems by pointing to a famous experiment as definitive proof. A team of researchers demonstrated that a concrete replica could be walked 100 meters in 40 minutes on a specially prepared concave road surface. This is presented as conclusive evidence that the method is viable. But a controlled experiment on a custom-built track with a modern team is not a real-world logistical operation. The island of Rapa Nui is not a paved laboratory. It's a rugged volcanic landscape with steep hills, deep valleys, soft soil, and countless unpredictable obstacles. Stop buying it. A 40-minute demonstration on a perfect surface is a great proof of concept, but it proves nothing about scalability. How does this demonstration scale up to moving 900 statues, each weighing up to 50 tons, over miles of unprepared, uneven, and unforgiving terrain for 400 years? The very existence of these concave roads presents another logistical black hole in the official story. If the walking method requires these carefully engineered paths for stability, as the experiment suggests, then the Rapa Nui would have had to build miles and miles of custom highways across the entire island. This is a massive infrastructure project in its own right, a task potentially as labor-intensive as carving the statues themselves. You would need teams to survey the routes, clear the land, excavate tons of soil to the correct concave profile, and then constantly maintain these roads against erosion from wind and rain. Do the simplest check. Look at the archaeological record for evidence of this island-wide engineered road network. While some ancient paths do exist, Where is the proof of a comprehensive system of concave highways sufficient to support the transport of nearly 1,000 moai? Or is this another case of stretching a small piece of evidence to cover a massive, unbridgeable gap in the official story? Let's turn our audit to the quarry at Rano Raraku, the supposed single source for the tuff used in the statues. The story here becomes even more convenient and contradictory. It claims that the quarrying process conveniently enhanced soil fertility in the surrounding area, creating a perfect synergy between heavy industry and agriculture. But a quarry is an industrial site, not a community garden. Be honest. Any large-scale quarrying operation generates enormous amounts of sterile dust and waste rock that smother the surrounding landscape, poisoning the soil and polluting water sources. You can analyze the soil composition around any major modern quarry. They are not noted for their agricultural productivity. The claim that the largest industrial project in the island's history was also a helpful farming subsidy feels like a convenient fiction designed to solve a problem that the theory itself creates. How could the island's primary statue factory and a vital food-producing area coexist without massive conflict over land use, water, and labor? The physical scene at the quarry presents another deep contradiction that the official story struggles to explain. We see hundreds of statues left there in various stages of completion, from barely outlined figures to nearly finished giants. The official story explains this by saying that production simply stopped around the early 1700s as a result of resource depletion, deforestation, and social upheaval. But the physical evidence in the quarry doesn't look like a gradual, planned shutdown. It looks like the workers dropped their tools in the middle of a shift and walked away forever. You can check the published archaeological findings, the placement of the basalt picks, the state of the half-carved figures. It has the eerie quality of a project frozen in a single instant. A gradual decline would show a tapering off of new projects and the careful completion of existing works in progress. This looks like a sudden, catastrophic stop. How does the slow decline theory account for the pencils down moment that is frozen in the rock? This brings us to the famous buried moai, the iconic images of giant heads sticking out of the ground that define Easter Island for most of the world. The official explanation is that these are complete statues with full torsos and hands that were slowly buried over centuries by the natural buildup of wind-blown soil and eroded sediment from the quarry above. Excavations have confirmed the statues have full bodies, and we can check the soil stratigraphy to estimate deposition rates over time. But the explanation feels radically insufficient to explain the sheer drama and uniformity of the visual evidence. It is too neat, too placid, too slow. It dismisses what we are actually seeing. Rows of giants buried up to their necks in a remarkably consistent fashion. How does a slow, random, gradual process of erosion and deposition create such a consistent and dramatic effect across so many massive statues in different locations? The visual evidence itself strongly suggests a more rapid and widespread event. Slow accumulation of soil over hundreds of years would be uneven, dictated by local wind patterns, rainfall, and topography. Some statues would be buried deeper than others. Some areas would accumulate soil much faster. Yet the image we are presented with is one of consistent, deep burial, as if a single, massive depositional event washed over the landscape and settled. You cannot simply ignore what your eyes are telling you. The slow erosion story feels like a classic attempt to fit the evidence into a pre-existing, non-catastrophic theory.
rather than letting the evidence challenge the theory itself. Why does the official explanation for the buried statues feel so disconnected from the catastrophic image they present to the world? The official narrative of deforestation leading to the end of the statue building era contains another glaring internal contradiction. The popular story is that the islanders recklessly cut down all their trees to move the statues, leading to soil erosion, resource scarcity, and societal collapse. But the official walking theory of transport, the one supported by the 100-meter experiment, explicitly claims that no logs were needed for moving the statues. It was all done with ropes and manpower. Think. You cannot have it both ways. Either they needed vast timber resources for levers, rollers, and sledges, which directly contradicts the walking theory, or they didn't need logs, which means deforestation, while ecologically devastating, cannot be the primary reason the transport of statues stopped. Which part of the official story is the fiction designed to cover for the other? This is a pattern we see again and again when you put this narrative under any real pressure. The official story is not a coherent system.
It is a collection of convenient, yet mutually exclusive components. The tuff is soft enough for easy carving, but is somehow strong enough for percussive, high-impact transport. The D-shaped base is a clever feature for walking, but is also inherently and dangerously unstable. The quarrying was a massive industrial project that also magically improved farming. The transport required no logs, but deforestation is the reason the entire culture collapsed. Each piece of the story seems tailor-made to solve one specific problem in isolation, but when you assemble them into a single production system, the whole machine is riddled with logical inconsistencies and fatal design flaws. It fails the most basic audit of its internal coherence. How can an explanation be considered sufficient when its core components actively contradict each other? Let's reconsider the labor force required for this operation, because the numbers don't add up. A team of 15 to 20 adults is cited for a single transport crew. But what about the hundreds of carvers in the quarry? The legions of rope makers, the tool makers, the road builders, the managers, and most importantly, the farmers and fishers, growing the food surplus to feed this entire non-productive army. The total labor pool required to sustain this centuries-long industrial effort would have been immense, especially for a small, isolated island population with a finite carrying capacity. You can estimate the island's population and the labor requirements for the moai project. A significant percentage of the entire adult population must have been dedicated, directly or indirectly, to this single industry. This wasn't a side project. It was the central organizing principle of their entire society. How did they manage this massive labor allocation without compromising their ability to perform the essential tasks of daily survival? The official story completely lacks a sense of the brutal trade-offs that any real-world project of this scale would involve. Every adult carving a statue or pulling a rope is an adult not tending crops, not fishing, not building houses, not caring for the community. Every pound of food fed to a quarry worker is a pound of food not available for another family. On a resource-limited island, these are not trivial decisions. They are life and death calculations made every single day. The romantic narrative of elites commissioning statues for prestige fails to capture the immense opportunity cost borne by the entire population. Stop buying it. What happens when the system is strained, when a drought hits or the fish stocks decline,
and a huge portion of your most able-bodied workforce is locked into a high-risk, non-essential industry like statue building. What breaks first? We are told the story of the Rapa Nui is one of master Polynesian navigators who settled this remote island around 1200 CE, and then, for some reason, immediately launched into this massive, risky, and wasteful endeavor. But these were skilled survivors. Any practitioner will tell you that survival cultures are, by absolute necessity, masters of risk management and resource conservation. They do not waste things.
They do not take unnecessary risks, especially not with their most valuable people and their most sacred projects. Yet the official moai transport story is a story of nothing but spectacular waste and existential risk. It's a story defined by a 1 in 7 failure rate, fragile materials, unstable designs, and lethal working conditions. This is not the signature of a resourceful, intelligent, survival-oriented culture. How do we reconcile the image of the master Polynesian navigator with the image of the reckless, bafflingly incompetent project manager? The whole official story feels like a collection of academic solutions that have never been pressure-tested against the unforgiving constraints of the real world. The physics might work in a computer model. The experiment might work on a prepared track with a modern crew and modern ropes. But when you factor in material fatigue, human error, unpredictable weather, resource scarcity, and the brutal, unforgiving logic of risk, the official narrative of walking statues begins to look less like ingenious engineering and more like a logistical fantasy. It's a story that works on paper, but would shatter into a million pieces on the rocky roads of Rapa Nui. How can we accept a theory that consistently ignores the most fundamental, real-world constraints of physics, economics, and human behavior? This consistent failure of the official narrative forces us to examine an alternative hypothesis. This is not the official story, and we must be clear that it is labeled a hypothesis for a reason. The hypothesis is that the statues of Easter Island are not the idols of an isolated tribe, but are the submerged peaks of monuments belonging to a lost continental landmass, sometimes called Pacifida. Under this model, the statues were carved in situ, right where they stand today, on a vast plain that was later inundated by a global hydrodynamic shock event. This explanation fits the observed constraints by completely eliminating the central, unsolvable problem of transport. It explains the presence of nearly 1,000 multi-ton statues without resorting to an absurdly high-risk, high-failure delivery system. It accounts for the buried appearance of so many moai, not as the result of slow, gentle erosion, but as the high watermark of a single, catastrophic flood. It resolves the contradiction of a production process with a 15% failure rate by proposing there was no production line, no transport, and therefore no possibility of transport failure. The official story of the Rapa Nui and their walking statues is a compelling tale of human resilience. It is supported by clever experiments and dedicated archaeological work, but it fails to survive a basic forensic audit. It fails to adequately explain the central, fatal contradiction at its heart: the willing, centuries-long adoption of a transport system with an absurdly high failure rate, immense risk to human life, and a core design that seems engineered for its own destruction. The story asks us to believe in a culture of master craftsmen who were also simultaneously bafflingly incompetent project managers. It papers over the brutal realities of logistics
material science, and risk management with a narrative that is convenient, but, under pressure, ultimately falls apart. The official explanation remains insufficient. If you demand explanations that can withstand a cross-examination against real-world constraints, subscribe for more breakdowns.